Hello everyone, welcome to my channel My Tech Notes. So whenever you go for a Java interview, it is very obvious that interviewer will ask questions related to core Java. That includes OOPS concepts, collection framework, or error handling, because this is the base of any of the Java version. So as a fresher, beginner, or an experienced candidate, the chances of the questions from these concepts increases. Okay, so I have already posted one video on OOPS concepts. Please check that video from my channel library. So in this video we'll discuss about the most frequently asked interview questions from collection framework. This is a part 1 video that will include most of the definitions, like what is collection, what is the hierarchy of collection, what is list, what is set, okay, what all interfaces are there, what all classes are there, what is a map. And in part 2 I will cover all the differences uh, uh, in between the interfaces, in between the classes. Okay, so because those are also most frequently asked questions during a collection interview. Let's start with part 1 first. So without any delay, let's start with part 1. What is collections framework? Collections is it's a framework that holds a single unit of objects. Okay, it is a single unit of object that allows us to perform some manipulation tasks, that allows us to sort and do other operations like insertion on the objects that are available in the collection. So collection, it's a ready-made architecture that is used for storing and manipulating a group of objects, and this collection framework is built up of interfaces, classes, and algorithms. Further we will see what all these classes and interfaces. So this is a hierarchy of collection. This is the most frequently asked question, like what is the hierarchy of collection framework. Even if interviewer does not ask you about a hierarchy, you can tell them that you know about the hierarchy of collection framework, and you can tell them about this because it will give them an impression that you already know about it. So first of all, in the hierarchy comes the iterable interface. It's a root interface, and this is the interface that provides us iterator interface, okay, that is used for traversing a collection object. Next is collection interface. It extends the iterable interface, and it also has its own functions like add, size, add all, remove. Okay, further, list, set, queue, these three interfaces extends collection interface. Okay, so the classes that implement these interfaces have all the features that are provided by collection interface. So the classes that are implemented by list, that implement list interface, are array list, linked list, vector, and stack. Classes that implement set interface are hash set, linked hash set, tree set. Tree set implements sorted set and set. Okay, there is a interface like dq that extends queue interface. Okay, and the classes that implement queue interface are priority queue and array dq. Okay, so this is a complete hierarchy of collection framework. So complete collection framework is based on that only. Let's move further. And one more thing, all these interfaces and classes are part of java.util package. So next question is which is the root interface in collections? So iterable is a root interface in collection framework, and it is extended by collection interface, and that is further extended by list, set, and queue interface. There are lots of classes and subclasses that implement these collection interfaces and also implement iterable interfaces. Okay, the only abstract method that it provides is iterator, and this iterator helps you in reading any collection object element by element. Okay, and it provides us methods like has, next, iterator. Next question is, what is the difference between collection and collections? This is also a very important question. So collection is an interface that is extended by list, set and queue, and this interface itself extends an interface that's iterable. The classes and subclasses that implement other interfaces by default implement collection interface also. Okay, so it gives us methods like add, remove, size, contains, etc. Collections is a utility package in collection framework, and it provide only the static method that can be used directly, like sort, min, max. You don't need to implement these methods. These are already available in the collections class. Next is what are the different interfaces in collection framework, as we have seen in the hierarchy. So this is just an explained version of that. We have seen iterable collection. So iterable is a root interface, as we have explained earlier, and it is further extended by collection interface, which is further implemented by other classes and interfaces. So this interface return iterator interface that helps in traversing a collection, and collection interface is the second interface that extends the iterable interface, and it has methods like add all, contains, remove, size, etc. And the sub interfaces that extend collection interface are list, set, queue. So list interface extends collection interface. This list interface can store ordered collection of the objects, and it allows duplicate values also. Okay, while set interface also extends collection interface, but it stores unordered set of elements, and it does not allow duplicate values in it. Okay, it can store one null value, overall one null value in the set. So the classes that implement list interface are array list, linked list, vector and stack, and the classes that implement set interface are hash set, linked hash set, tree set. Next is sorted set. Sorted set is subset of set interface, or you can say it extends the set interface as it provides an ordering of the elements. Okay, because set does not have ordered collection, ordered set of elements, but sorted set provides an ordered set of elements. Okay, so it contains in ascending order or in descending order. In particular order, it stores the elements. Okay, next is queue interface. Queue interface also extends collection interface, and it follows the strategy of first in first out order. Okay, the classes that implement queue interface is priority queue. Next is dequeue interface. Dequeue is also a sub interface of queue interface. It extends queue interface. By dequeue we mean double-ended queue, in which elements or operations can be performed from at both ends of a queue, and it is implemented by array dequeue class. So all of these are the interfaces that are available in collections framework. Okay, now again, one of the most important question, how is collection different from array? Because array is also used for storing objects or primitive data types, primitive datas. Okay, while collection is used only for storing objects. So that's one of the difference. But how can we make sure that how can we explain that what all differences are there? So array is of fixed size, collection is scalable, performance of array is faster than collections. Array stores homogeneous components, while collection store homogeneous heterogeneous, means it can store objects of different types. Array does not provide any built-in function. If you want to perform any operation on the data, you have to write it down by yourself, and then you can execute those functions whenever it is required. While in collection, it comes with lots of built-in functions like add, size, contains, remove, etc. So you can use them directly. So that increases the performance also. Okay, now array can store objects and primitives data types, while collection can only store objects. So these are the difference between array and collection. That's why you cannot use collection in place of array, or you cannot use array in place of collection. Now here is the map hierarchy. Map is also a part of collection framework, but it is different from iterable collection interface. Map is one of the just like iterable, map is also a root interface as it does not extend any other interface. Okay, a map has a sub interface that is sorted map, and the classes that implement map interface are hash map, linked hash map, tree map. We'll discuss them in coming slides. So what is a map interface? Map is one of the root interface as it does not extend iterable collection interface. It is a part of package java.util.map. It does not allow duplicate keys, but it does not allow duplicate keys, but two different keys can have same values. Okay, the classes that implement map interface are hash map and linked hash map. Both of them, hash map and linked hash map, they allow null keys and null values. Tree map implements sorted map interface and it does not allow any null key or value in it. Okay, so this is a map interface. This is just an overview of it. Why map interface does not extend collection interface? Yes, that's what we have seen in the hierarchy, that map interface is not extending collection interface. But why? See, map is a stores objects in the form of key value pair, while collection stores objects in the form of single object, right? So they have incompatibility issues, okay, due to which map cannot extend collection interface. And how can we explain this incompatibility? Say, if in collection, if we have to add an object, we will use the collections method, that is add object method. Okay, that will work only for one object. But in map we have to if we want to add an object, we have to give key and value for it, right? So key and value can be an object, can be object. Okay, so map has a method that is called put key value for this. We cannot add key value in the add method of collection. So you can see, so there is an incompatibility. So that's why map interface does not extend collection interface. What are the advantages of collection framework? Why do we use them? So first of all, consistency is the main advantage of collection framework, since classes like array list, linked list, hash set, priority queue, all the classes, subclasses, they implement core set of interfaces like list, set, queues, which are further extending collection interface, right? So basically all of these classes and subclasses have the same set of functions in it, okay, like add, size, contains, add all, okay, remove. So that means you don't need to write them. You have a design and functionality that will remain same throughout the collection framework, right? So that's the main advantage of collection framework. Next is less programming effort. These are inbuilt functions, so your programmer does not need to worry about writing them. Next is improve program speed and quality. So a programmer does not need to worry about the performance of the project. Okay. Next question is what is enumeration? So enumeration is also a kind of iterator that is used to read elements in an object. So it is a legacy interface that is used for traversing legacy classes like hash table and vector. Okay, enumeration is different from iterator. How? Enumeration is a read-only interface that can just read the elements of an object, but it cannot perform any operation on it, like it cannot remove any element on it, while iterator at the time of reading and traversing a collection, it can remove elements from it, right? So that's the major difference. So enumeration is read-only interface. You can only go through the data, but you cannot make any changes. So enumeration uses enum data type that is defined by the user, and it is a kind of static constant value that is used for traversing a collection. So this is called enumeration. Next, now this is also one of the important question from collections framework, that is what is comparable. Whenever there is a question for comparable, there will also be a question about comparator. Okay, so that will be coming in our next slide. So first of all, let's see what is comparable. Comparable is an interface that is a part of java.lang package. It is used to sort object based on single attribute like id, name or price. And the comparable attribute, the comparable interface, while using comparable interface, the real class that uses it gets changes. Okay, is affected by this when it uses comparable interface. And comparable interface has provides a single method that is compared to, that needs to be overridden by the class that implement comparable interface. So let's see an example of comparable interface. So here is an employee class. So here is an employee class. Okay, so here this is an employee class that we want to sort based on experience. Okay, so it has fields like rank, experience, name. We want to sort it based on employee's experience. So this employee class has implemented comparable interface using that uses employee object, right? So here is a constructor defined, toString method defined. Since it is implementing comparable interface, it has to override this method as compared to method, and in this it is passing an object that is employee. Okay, and inside compare to method, we have to provide a definition, a method definition, where we are comparing the field on which we want to sort, that is experience. So we are comparing this object's experience with the parameters object, argument object's experience. Okay, so if it is equal, then we are returning 0. If it is greater, then we are returning 1. If it is less than the object's experience, argument's experience, then we are returning 1. Okay, now coming to the main class. This is a main class where we have defined public static void main. In this we have created an array list of employee and added 4 employees in it with experience of 5, 14, 1, 20. Okay, and we want to sort this employee based on the experience, right? So we have added these 4 employees in the array list, and let's print out this array list here. Okay, so it will print the values, we'll see the result. Okay, and here collections.sort, we have used collections utility, so that provide us a sort method. So we have used collections.sort. In that we have passed this array list, that is employee array list. That's employee array list. So we are using collections utility that here. So it has a method called sort. So in this sort method we are passing array list object. Okay, AR. Okay, so as per the solution, it should sort this array object based on this compare to method. Okay, that we have added in employee class. Okay, so here we are printing it again. So let's execute it. So this is the unsorted array list of employee. So employee 5 with experience 5, 14, 1, 20 are here. These are not unsorted values that we have entered in the array list. And after sorting using collections.sort, we have employees in the ascending order based on experience, like 1, 5, 14 and 20. Okay, so this is the implementation of comparable. Next is, okay, let's go back to the slide. Next is comparator. comparator is an interface that is present in java.util package. It is used to sort different objects. Okay, it can sort collections based on different criteria like id, name, price, experience, name, age, etc. Okay, using comparator, real class does not get affected, unlike comparable. It provides a method called compare that accepts two objects, object 1 and object 2. So we can sort two objects in it. Okay, let's see an example of comparator also. So here in comparator, we have defined an object called employee, object class employee. So it has fields like rank, experience, name. Okay, that's it. Now for sorting an employee with experience, by experience we have defined a class called sort by experience. It implements comparator, and it is overriding a method compare and passing two parameters, that is employee o1, employee o2, and inside that it is returning o1.experience minus o2.experience. So based on the value, if it is 0, 1, minus 1, it will return, it will sort the employee class. So in the main class, we have under public static void main, here we have created an array list of employee. Here we have printed the unsorted version of employee. Then under this is collections.sort, we have used sort method of collections, and we are passing array list and new sort by experience, instance of sort by experience class, this one. Okay, so what it will do, it will sort the employee class. Okay, so here, like you can see, it will sort the employee class based on two objects, okay, o1 and o2. So it is passing same employee classes it is passing two objects of the employee class and sorting them. Okay, let's execute it. Right, so this is the unsorted version of employee class with experience 5, 14, 1, 20, and here is the another version 1, 5, 14, 20. Okay, now the thing is, as we have read in the definition, that comparator can sort the objects based on multiple parameters. So here we have sorted it based on experience. We can also sort it based on its name. We can also sort it based on its rank. Only thing is, we have to define new classes for them and call collections.sort, right? While in case of comparable, we can sort only on one parameter, like we have done in based on experience only. Otherwise we have to write down our own code. Okay, so you understood that. Good. Now let's get back to our slide. So now we are clear what is comparator. Okay, now this very simple question, I mean you must have seen it hierarchy also. Interviewer can ask you, so what all classes are there that implement list interface? So array list, linked list, vector, stack, these four classes implement list interface, out of which array list is non-synchronized and it allows duplicate elements. So what do you mean by non-synchronized class? Non-synchronized class is a class that allows multiple threads to operate on it. Like if one thread is performing add operation, another thread can do remove operation on it. So that's what we call non-synchronized list. Okay, another one is linked list. Linked list is double linked list that can store elements, or it can also store duplicate elements. It is faster because no shifting is required. Vector is a dynamic array. It is synchronized. By synchronized we mean that only one thread can work on it at a time. Stack is a subclass of vector. It implements last in first out data structure. Okay, next is classes that implement set interface. Hash set, linked hash set, tree set. So hash set is a class that implements set interface. It uses hashing for storing the elements. It contains only unique elements in it. Okay, how does it make sure that objects are unique? each object that we have to store in hash set should override equals and hashcode method to ensure that duplicate values are not inserted in hash set. Okay, linked hash set, it extends hash set or implements set interface. It contains unique elements. It also maintains order of those animals, and it permits null values. Tree set is a ordered form of hash set. Okay, it implements set interface like hash set. Tree set also contains unique elements, but the access and retrieval time in tree set is fast. It stores the elements in ascending order. Now, so what all classes implement queue interface? Priority queue and array dequeue. Priority queue class implements queue interface as it holds the elements on objects that are to be processed by their priority. As queue interface follows first in first out, right? So priority interface also implements a queue interface, so it follows the first in first out procedure. It does not allow null values to be stored in the queue. Array dequeue implement dequeue interface, and this dequeue interface extends queue interface. So array dequeue follows double-sided queue strategy. It allows us to add or delete items from both ends. Now, classes that implement map interface are hash map, linked hash map, tree map. Hash map implements map interface. It allows null keys and values. Okay, but it does not maintain any order. Linked hash map also implements null map interface, but it allows null key and value. It maintains insertion order of the objects. Tree map implements sorted interface, but it does not allow any null value. It maintains ascending order of the objects. So these are the most frequently asked questions from the collection framework. Other type of question that can be asked are difference, like what is the difference between list and set versus what is the difference between array list and vector. Okay, so these kind of questions I'll be preparing. I will share part 2 with you very soon. So please keep watching. You can also suggest me in comment box what all videos you want me to prepare for you, what all technologies you want me to cover. Okay, so all the best for your interviews. Thank you.